Hey guys, how's it going? So what we're going to do today is we're going to combine the idea of volumes of revolution and the area between two curves. So what we're going to get is the volume that you get by rotating the area between two curves. Okay? So what I've got here is a simple sketch of two curves, F and G, right? They happen to be straight lines, but the concept will work the same. And we're going to try to take this area and we're going to try to rotate it around the x-axis. So we're going to take A and we're going to take the function f of x and we're going to rotate it all the way down, right? So we would get this three-dimensional figure, right? Then what we're going to do is we're going to take G and we're going to rotate that as well. Okay, so I rotate G as well, and what we get is it creates this cylinder in the middle. Okay, so what actually happens is we want to find the volume of this kind of donut shaped three-dimensional object, right? So it's hard to picture, but let's look at an applet which will hopefully make it a little bit better. So this is y equals x squared and y equals square root of x. Okay? So what we've done is we've taken this rectangle that goes from the x-axis to root x, and we've subtracted off the rectangle that goes from the x-axis to x squared. Okay? Now what happens when we rotate that rectangle? Well, we end up with looks like a washer, right? So we end up with that, and so you can see that at different places the washer is going to be the same, but what we're doing is we're taking the area underneath the top curve and we're subtracting off the area underneath the bottom curve. And what ends up happening when we revolve the region is we get a three-dimensional shape with a hole in the middle, right? So this is the volume that you get by rotating F, so pi r squared h minus pi r squared h. So we subtracted off the volume under G. Now, since they're both going from A to B, we can combine the integral into this, and we can factor out pi. So this is going to be the formula that we use to get the area, to get the volume bounded by the area between two curves. Okay, so you got to square each one separately. All right, so let's go to an example. So we're going to do y equals x squared and y equals root x. Okay, so here's the applet again. Root x, x squared. You can see that between 0 and 1 is where they're bounded. And again, we can find those by setting the two equations equal to each other and solving. We get x squared is equal to root x, right? Now I need to get rid of that square root, so I'll square both sides. So we get x to the fourth is equal to x. Then I move everything to one side, make it equal 0, factor, and we end up with x is 0 and x is 1. Right? So we know that we're dealing with an integral from 0 to 1. Okay? Now remember our formula, right? It's pi r squared, so the pi can come out, and now the top function is square root of x. Okay? So the top function is root x, so that's going to go first. Okay? So we're going to do square root of x squared, and then we're going to subtract off everything underneath x squared. Right? But that's got to be squared as well. Okay? So that means that it's going to be pi. And then let's simplify a little bit before we take the integral. So square root squared, that's just x, and x squared squared is x to the fourth. Right? So this is going to be pi, and now we're actually going to integrate, so we're going to get x squared over 2 minus x to the fifth over 5. and we're going to evaluate from 0 to 1. Okay, so we're going to leave the pi there, and now we're going to plug in 1, and you get 1 over 2 minus 1 over 5, and then we're going to subtract, and we're going to plug in 0, where you get 0 over 2 minus 0 over 5. So 3/10 of pi, or 3 pi over 10, that's the volume that you get by taking this area and revolving it all the way around the x-axis. So here we want to determine the volume obtained by revolving the area bound by y equals sine x and y equals cos x on the interval from 0 to pi by 2. Okay, so I've gone ahead and sketched this already, okay, using a graphing program, and recognize that we're going from 0, so we're going to cut it off there, to pi by 2. Well, that's around 1.6, right? So we can cut it off there. Okay, so we're looking for this area and this area, and we're going to revolve it. Now notice that just like before, the top and the bottom functions change. So what we're going to do is we're going to have to separate the two integrals, right? So we're actually going to have to do an integral from here to here, and then from here to here. Okay, so here you can see that the top function, and you know that that intersection is, I'm not going to solve it for you, but it's pi by 4. You can solve that with your graphing calculator. Okay, so we know that we're going to do the integral from 0 to pi by 4 of, remember, pi and then r squared. Well, the top function is cos x, so this will be cos squared x, and the bottom function is sine x. Right? Now, we can't integrate cos squared and we can't integrate sine squared. Okay? So we've got two options here. Option number 1 is, if you have a graphing calculator, use it. Okay? So your graphic display calculator, use it. Okay? So either you can type this in, or you can type in NINT, and then the function. Remember, you're going to have to type in everything like that, minus sine x squared, comma, your independent variable, lower bound, upper bound. Okay? And then you're going to have to multiply all this by pi, because it's pi times that. Okay? And that'll give you your area 1. Okay? And then you'll do the same thing for area 2, and you'll add them together. Okay? Option number 2, if you don't have a graphing calculator, you need to make this look like something that we've seen before and that we can integrate. Well, there is an identity that you do need to know. It's in your booklet, which you will have access to on the test. Okay? This is equal to cos 2x. Okay? So what you're actually looking for is pi times 0 to pi by 4 cos 2x dx. Okay? And we can find that integral pretty easily, because the integral of cos is sine 2x divided by 2 from 0 to pi by 4, which means that it's going to be pi sine, and then 2 times pi by 4 is pi by 2 over 2. So there's my upper bound, and then I'm going to sub in my lower bound, sine 0 over 2. Okay, so this is pi. Sine of pi by 2 is 1, so this will be 1 over 2, and sine 0 is 0. So this volume is pi by 2. Okay, so that's volume 1, and you'll get the same thing if you type this into your graphing calculator. Volume 2, I'm going to leave you to do. It would go from pi by 4 to pi by 2, and try the rest of the homework, and come Monday ready with questions. Alright, see you guys later.